Yeah, being in this space, I know I gotta hold my hold down. Seeing what it takes, I gotta know that I can show. I questioning myself if I believe it though. No longer question.
Hello everyone, welcome to the show In Code We Trust. I am Paresh Masani from Token Metrics team. Today I'm going to do a technology review of Hedera Hashgraph project. Please note that this is not a financial advice. Always do your own research before making any decision. As usual, I will be going through the technology scorecard metrics that we use at Token Metrics to validate the technology strength of the project. So let's start with some of the initial screening questions which are very important at Token Metrics. So first of all, does this project need to use blockchain technology? I would say yes. Hedera Hashgraph is based on the DAG, which is direct acyclic graph-based blockchain rather than the conventional blockchain. And it has implemented proof-of-stake consensus mechanism. Second, can this project be realized? I would say yes. Hedera promises a very scalable, high throughput solution with more than 10,000 transactions per second and with very low average transaction fees. And Hedera Hashgraph public beta mainnet is already been live since September 16, 2019. Third is there a viable use cases for this project? I would say yes. They have mentioned mainly the three use cases here. One is cryptocurrency payments that allows fast and low fee payments. So HBAR, basically the native token for Hedera Hashgraph blockchain, can be used for micropayments. The second use case is tokenization of asset using the smart contract written on Hedera blockchain using the Solidity language. And the third, I would say, is a file service, basically to anchor the external data on the Hedera public ledger. So I think there are many projects already provide these services already. I guess I don't see much unique about the use cases itself, but there is a uniqueness in the underlying technology that they have implemented. So let's go to the next initial screening question, which is this project protected from commonly known attacks? I would say yes. So Hedera Hashgraph has implemented asynchronous Byzantine fault tolerance algorithm with virtual voting, which is their uniqueness of the underlying technology. So with asynchronous Byzantine fault tolerance algorithm with virtual voting consensus protocol, they are able to address most of commonly known attacks. We will see in brief detail in architecture section. And their white paper is, I didn't find any obvious issues. Right, so let's go section by section. The next is innovation. So where we will be looking at a few questions. The first question is how have similar projects performed? Well, I would say there are many projects using the same technology or similar technology and similar use cases, but none of them have proven solid in real life use cases scenarios. I think maybe it's because we yet to see the blockchain adoption. And the Hedera Hashgraph is focusing on very few things, which is good about it. The percentage of crypto users that will use the project, I would say a very few, because as I already said, there are already projects and similar use cases out there, right? But most of the projects fail to keep the momentum after the mainnet release. And same with Hedera Hashgraph, they have released their mainnet like on September 16, but I don't see many dApps or applications developed on it after. And the uniqueness about this project, for that, let me go over here. So yeah, I definitely like a few things about this project. One is the proxy staking. So this is coming soon. It is basically enable you to incentivize from your HBAR tokens. If you don't want to run the node yourself, then you can lend that tokens to the people who wants to run the node, and you can incentivize from the earnings. The second thing I like about is the way they have implemented the gossip protocol. I would say like gossip about the gossip, right? We will see that in architecture a little bit detail. And the third is the virtual voting, which is their unique concept, basically like without doing actually voting, they come up with the consensus. That's the beauty about the virtual voting algorithm that they come up with. Right, next section is architecture. So some of the data points that we consider here is mainly the white paper, overall architecture, and possible attacks resistance. So regarding overall feeling after reading the white paper, I would say that they have a great white paper, covering performance, security, fairness, governance, compliance, and everything is explained very much in detail. They have also given a mathematical proofs about the certain concept at the end of the white paper, but we are not going to go over it in this video. So the next data point is resistance to possible attacks. For this, I want to go over two things. So one is network protection. So what they're saying here is the weighted voting, right? So basically, uh, this concept, right, makes it difficult and expensive for bad actor to maliciously affect consensus. What that means is uh, they have to stack a lot of HBAR in order to participate in the consensus mechanism, right? And more HBAR they hold or they stake, they have more weight, right? And if they have done anything wrong, they lose all their stake. Okay, but if they want to do really something bad, then what they need is they need to hold or stake at least 1/3 of network's total supply of cryptocurrency. So what they're saying is, which is not possible in first 5 years, basically. So yeah, at least first 5 years, this network is safe. All right, and the next thing I want to go over about the security aspect is they have implemented this asynchronous Byzantine fault tolerance algorithm, right? And and the way they have implemented this is little bit different than the actual algorithm, right? So actual algorithm does the voting as well to come up with the consensus, but they do voting over the internet. So they send the messages to each other. I mean, I'm talking of the nodes, of course. Um, so so sending the messages across the nodes is very expensive process, and that's why no one has actually implemented this algorithm so far, right? But what Hedera Hashgraph has done is they have used the virtual voting, right? So they still exchange the message, but they exchange the message very quickly using the gossip about gossip protocol, right, that they have implemented. And they are adding like only 2 hashes more that we will see in the next section, which is the complexity of the architectures. So let's jump into it. And I want to go over the white paper again to demonstrate that. I think the, let's say, go. This is very simple, but yet very powerful, and agree with this algorithm. So what this does is basically this is all nodes, right, that run by various people, and and the way they communicate with each other. So here is like Bob is sending message to Ed, right? Basically this message, right, what you see here, each bubble, what it contains is the signature of the sender, timestamp, transactions and the two hashes basically, which contains the information about the history of the transactions, right? So when Bob sends the message to Ed knows that what the DAG looks like for Bob, and then Ed knows, based on that information, how to make a DAG for himself. And each user does this with each other randomly, right? So there is no any particular sequence that Bob has to send Ed or Bob has to send Elias. No. So that's still a node selection is so random, and that's why it's very quick. So if you see, like, apart from sending this message, which is anyway happening in any consensus algorithm, there is no other voting involved, basically, right? So they come up with the consistent DAC based on these messages they exchange while doing the gossip. Right, and it says gossip about gossip is because, for example, the Bob is sending a message to Elias that what he sees as a overall graph or DAG, right? And Elias sent the same information to Carol. Hey, the Bob is seeing this one. I see this one. What you see, right? I mean, come up with the consistent DAG based on this information, basically. Yes, it's beautiful concept. I really liked it. And the next thing I want to see is Hedera SDK JS. Let me open that. Yes, this one. So I like, this is a very beautiful concept as well. Why? Because they are using all latest technology. For example, they are using gRPC, like Google's RPC protocol, to communicate with each other node. They are using the decentralized uh, hash table, so which is solid. And I'm a big fan of this all Google's technology. Um, I think that's it. And the next data point is about the time taken to understand the architecture. I think is not very complex architecture, but it did take me about half an hour to understand it. And even though their the white paper, as I mentioned, is great, right? But apart from this gossip and virtual voting algorithm, I don't see much uniqueness, I would say. So I have given medium. So it's somewhere in between. Right, so let's go over quickly about the code quality. There are many data points for this section. First is this project open source? Yes, it is open source. They have deployed all their repositories on the GitHub. I think they have about 20 repositories. Does this project use the good code like C, C++? I would say yes. Actually, they're using Java, JavaScript, C, and the Go, which is one of my favorite language, and the TypeScript as well. And GitHub number of lines of code and commits per month. And basically, what we are trying to see here is how active they are in terms of the development, right? I would say they are very active. So there are so many commits being made daily, and the developer profile is also very solid. You can see that this is Hedera SDK, right, which is very important for any developer who wants to build app or any applications using the Hedera blockchain. Right, so this guy just picked up randomly. Here you can see, very active, right? This is basically his graph. They ran, yeah, I think he is also very active and with the GitHub like since 2011, which is amazing, all right? And the contributors, the graph is also looks very busy. But what I want here about the quality of the code, I have still given the good quality, but I found something bad. I mean, it's not too bad, but I was just going through the whole source code, and I come up with this commit. I think this one is about something like downloading file to validate the previous hash continues, right? So that's where they have made these changes. So the previous change was saying that, okay, is this sig file is exists, right? I mean, it's needed. If it is needed, then it compares that the whatever the object they have now with prefix plus last valid name, and that was the one condition actually. And if that condition, if they both is satisfied, then they check for all that this file name is empty. If one of this is true, then it goes inside. But it seems that there was something wrong with this one when they come up with this condition. Now, this condition is basically it checks for, okay, this sig file is needed, and the other condition is gone inside the or condition, right? But still, I think that sequence of this is wrong because you should be checking the last valid file name empty first, so if this is true, then it will not go here and check it again. I mean, this is just out of curiosity I found this commit actually, but apart from that, I mean, they're definitely following the best practices, and their source code is really good standard. The documentation, what I see here is like, how well they have documented all the repositories. So what I meant is, like if I come here, I can see, I mean, what is this repository all about to set up on my local machine, what steps I need to follow, which is very clear. And on top of that, they have very solid documentation here in docs.hedera. So anything that you need basically about developer tools and concept related things, and other documentation they have is for each of their use cases like cryptocurrency, right? So if you want to use their SDK to use this cryptocurrency APIs, yeah, you can, and it's very clear. Smart contract related documentation, and then file service related documentation. Everything is beautifully documented. So they're getting the full points there. And the maintainability index and the test coverage is very important for me actually. So I have found a very good test cases for them. So I will again go to this SDK, and yeah, they have the solid test case coverage. And the beautiful thing is they write the test coverage basically whenever they make any changes. And on top of that, they're using Docker and some beautiful concept, to manage installations and dependencies, basically, which I'm very big fan of as well. So the maintainability wise, definitely they are very high in terms of that outstanding, and test score is also good. So they got very high score for the code quality, I would say. Right, so the next thing is when their mainnet is ready. So it's already ready. So they got the highest point here because they already released public beta on September 16th. This is third time I'm saying that in this video. Right, so usability wise, I have given the medium because I don't see any obvious way that is very usable and user friendly for end users, actually regular users, but for developers, yes, very clear documentation of things. Right, so last thing is team, number of active developers, yeah, is more than 5. You already saw that. And developers average Git background, I already demonstrated that. Yeah, it's really good, solid. Developers coding style is solid too. So they have really scored well on team section as well. We haven't done in-depth technical analysis for this project. Right, so conclude this project, I would say Hedera Hashgraph is a strong project in terms of code quality and team of developers and the coding background. but they are a little bit lacking or weak in terms of innovation and architecture because most of project which implemented similar concept and similar use cases, as I mentioned, didn't do extremely well so far. Maybe we need to wait until we see the real blockchain mainstream adoption. So this concludes this video. Thank you for watching In Code We Trust. Goodbye. Take care.
Steve and Dave use eToro to invest in the financial markets. Steve does research on global investment opportunities. Dave does research on how to become a level 60 wizard. Steve follows the feed for the latest market news. Dave follows the feed for the latest cat videos. Steve has a watch list for promising investments. Dave has a watch list too. So why is Dave just as good an investor as Steve? It's because Dave used eToro's copy trader to automatically replicate Steve's trading activity. Whenever Steve makes a trade, Dave does too. Yes. Trade like a Steve with eToro, the world's leading social trading platform.
This the only life I know. I believe it in my mind, so I know it's time to show.